Does NAD really decline with age? You might have seen headlines recently claiming that NAD stays stable as we age, which challenges the common claim that it declines, a claim that is frequently repeated by many scientists, influencers, and supplement companies. What you might not know is that this new study is just the tip of the iceberg. Let's look at the new study as well as a previous review to see the bigger picture. In 2022, a review in a special issue of Nutrients on NAD in human health showed that in yeast, mice, monkeys, and humans, published research does not always show a reduction of NAD with age, and concludes, quote, "This poor-founded perpetuation of the idea that NAD plus levels universally decrease with age is misleading." A table in the review showed the variability in the research, split into sections for different species. I've condensed it even further into the following table to show an overview. We can see here that in the pooled data, NAD plus levels declined with age in humans in 75% of the studies prior to 2022. The review also looked at limited evidence in rhesus monkeys, suggesting an increase in NAD plus with age, with middle-aged monkeys having 2 times more and elderly having 2.5 times more. Not only that, but even in the studies showing decline, there is significant variation in the amount of decline. The reviewers go into several examples in the human data where the difference in NAD plus levels between young and elderly people is only 10 to 20%. That's very different to the 80% claim we see floating around. Finally, the reviewers concluded that there may be an unintentional selection bias in the published evidence, because researchers may be less likely to report on a biomarker when it doesn't change. It's just not as interesting as the ones that do change. If that's true, it means the true numbers from all gathered data could be very different to those in the table. The new study making headlines used 7 separate cohorts, so we could either include it in the table as one study to bring the percentage down to 69%, or as 7 studies to make it 47%. The paper includes 2 figures. The one on the left shows NAD plus increasing with age in humans, and the one on the right shows the median NAD plus levels increasing after increasing exercise and protein intake. This study is noteworthy for a few reasons. Firstly, having 7 separate cohorts validating each other's information is amazing. For comparison, the interventions testing program, which is deservedly seen as one of the most rigorous testing programs in the world, uses 3 separate mouse cohorts for each test. It's published in Nature Metabolism by 32 authors from the Netherlands, Spain, Finland, and Australia. They even made the discovery that freezing and thawing blood samples reduces NAD plus levels, which might account for some of the variability across previous studies and will certainly lead to improvements in future studies. Overall, this research paints a picture that NAD plus might not decline with age, but we should be careful not to overinterpret the results. This is not the same as saying that low NAD levels are a good or a bad thing. It just means the logic of it goes down with age, so you should supplement its precursors as you get older might not be right, especially since higher levels of NAD might also feed cancer cells. It could make sense to transform that logic into you should measure and track your NAD plus levels, and if they get too high or low, intervention might be a good idea. I'm trying to get more subscribers, so please consider subscribing for more content like this. I'm also interested to know whether this research has changed your supplement stack and whether you like this kind of article where I interpret and give context to popular new research. Let me know in the comments.